The next important OOPS concept is polymorphism. That means it having many forms. Okay. So for example, add is a function. Okay. When I am inserting 5, 3, it must be add the number. When I am giving add a, b, it must be add. It must concatenate the two strings. So the same function with different action based on the data. Based on the data, the same function acts differently. So such concept is called as polymorphism. Such implementation is called as polymorphism. Polymorphism means having many forms with same name. It occurs when there is a hierarchy of classes and they are related by inheritance. Normally this is also occur in the hierarchy of classes. Whenever you are creating an inheritance, that time it is happening. Here we are going to see 2-3 concepts: function overloading and operator overloading. Okay, function overloading means it allows you to specify more than one definition for one function name is called as function overloading. Okay, when more than one definition for one operator is called as operator overloading. So in this polymorphism, that is more than one form, right? So that polymorphism, it will become under function overloading and operator overloading. Okay, two things. One, function overloading means it allows you to specify more than one definition for one function name. More than one definition for one function name is called as function overloading. So when you are defining more than one definition for one operator, it is called as an operator overloading. So now we are going to see function overloading. See, this is function, void print is a function. Here also void print is a function. The function name is same, but it will be differed with the arguments. So here I am going to pass integer I. Here I am going to pass float j. See out integer parameters passed. And then you see here float value based passed. So if I call print, okay, print 5, this function will be called, okay, and the output will be integer parameter passed. If I call the function as print 6.8, so this function will be called and it will give the output float value based. So this is called function overloading. Based on the data, my process will be changed. Printing is a process, okay. This process will be changed based on the data. If I send an integer data, that integer function is called. If I send the float data, then float print function will be called. So this is called function overloading. Same name with different arguments is called as function overloading. Okay. And the next important thing is operator overloading. Operator overloading means I am defining a. So in operator overloading means we are defining the new meaning for the existing operator. For example, see, normally if you do a plus b, what is operator? This is operator, this is operand. Okay, so if I give 5 plus 3, normally it will print 8. So now I am going to define a new concept for this operator. So what it is that, so I am going to use object in the place of operator. So if I want to give a new meaning for the operator, I have to use class. Okay, this box. Okay, this object. Okay, class name operator plus constant box ampersand b. That means here this box 2. Okay, what happened? This box 2 object is the copy of this object of this class box, and this here is this one, box 1. Okay, see, no, box 1 is some set of object. You can have 100 of values, and box 2 is another object of a class. You have a number, name, and something. So this uses, you can add within a single operator. This is an operator overloading. Okay, I'm giving a special meaning for this operator. This box1 object, some set of objects will be added to the box2 with it has the same quality of an object for the box. Understood? See, this box has x and y value. So you consider there will be 100 of values of box 1 x, 100 values, and you consider box 2 has 100 of values. If we want to add this box 1 value and box 2 value, two objects, see, I created an object for box as a box 1, and here I created two objects, and third object which is the addition of these two objects. So box 3 equal to box 1 plus box 2. What happens? It will call this operator overloading. So operator is the keyword, and this is the class name plus const this class name and then ampersand. So this will be indicated by box 2. So now I created an object v1, and v1 dot x equal to this dot x. This means current object, this box 1. This box 1 dot x plus this b. Okay, this b is nothing but box 2. So box 2 dot x value, and then current object b1 dot y plus b2 dot y. So this value will be added and placed in this. This is nothing box 1 and box 2. Okay, this added and b1, and it will return this b1. This b1 value is nothing but box 3. That is, third object is created. So this concept is called as operator overloading. The next important thing is virtual function. Virtual function is a function in a base class that is declared using the keyword virtual. It signals to the compiler that we don't want static linkage for this function. Okay, there is no static linkage for this function. When you are defining as a virtual, it cannot directly call. It's a virtual. Virtual means what? See, we cannot able to see, right? We cannot, but we can able to feel. We can inculcate into another function. That's a virtual. Okay, this is virtual function. We will see in an example so that it will be easily understood. And the next one is the selection of the function to be called at a given point in a program to be based on the kind of object, which is called as dynamic linkage or dynamic binding, which is I explained in the function overloading. See, at the time of value I passed, based on that I call that function. Right? If I pass on integer data, the integer function will be called. If I pass the float data type, float function will be called. So that is called as function overloading. Right? That is also called as dynamic linkage or dynamic binding. So on this will be come under polymorphism. This function overloading and operator overloading and virtual function. Virtual function is don't have a static linkage on the function. Don't have this, just remember, virtual means don't have one static linkage for that function. See, for example, this is a class shape, and here I declared a function name area. This is parent class, and then class rectangle. This is a class 1, and this is class 2. In a rectangle is a function class that I inherited this shape inside this, and then here also I am using int area. Okay, this is a rectangle area, and then class triangle is also another third class. Here I declared public shape. I inherited this shape class inside this triangle, and see out parent class. This is triangle class. See out triangle class, and now I call void main function. From here only the process start. Shape star s1. So for this shape I created an object s1. Now I call this s1 dot area. Which function will be called? Either this or this or this. This everything is a normal function. Int area, int area, int area. So what happens? This s1 dot area will call this shape of area function. So the output will be parent class area. Clear? Yes. Now I want to call this rectangular area. Rectangle area. How can I call that? By using the virtual keyword. Okay. So define virtual in this place. This is first program and second program and third program, right? So now there is no static linkage between this object and this function. Okay, what I am doing is shape star S1. I created the object S1 and then also I created rectangle R1. I am passed this R1 object to this S1 and then I am calling this area. So now it will call this rectangular function. Then the output is rectangle area. Okay, this is the use of virtual keyword and virtual function. There is no static linkage between the functions. So it created the S1 object. Here that I passed the rectangular object address. So that's why if I call S1.area, it calls the rectangle class. That's it.